Isaac Newton, born prematurely on Christmas Day 1643 in Woolsthorpe, a small English village, had a life marked by adversity. His father died months before his birth, and his childhood was spent in an atmosphere of solitude and fragility, due to his delicate health. Raised by his grandmother after his mother's second marriage, Newton found refuge in his own mind, developing an extraordinary curiosity about the world around him. From a very young age, he showed a great interest in the mechanisms and functioning of things, building models of windmills and sundials and studying with fascination the natural phenomena he observed in his environment. This passion for knowledge led him to the University of Cambridge, where, although he did not initially stand out for his academic results, he found his true calling in mathematics and physics. Popular legend has it that it was the fall of an apple in his garden that sparked his interest in gravity, but the truth is that his mind was already primed to connect everyday observations with universal laws. At Cambridge, Newton immersed himself in the work of scientists such as Galileo and Kepler, absorbing their ideas and laying the groundwork for his own research. The isolation caused by the bubonic plague in 1665, far from being an obstacle, became a period of intense creativity and concentration, where his ideas began to take shape. In this time of forced retirement, Newton laid the foundations of infinitesimal calculus, conducted crucial experiments with light, and formulated the first ideas about gravity. His insatiable curiosity, unwavering determination, and ability to observe were the seeds that gave rise to one of the most brilliant minds in the history of science. Newton's genius flourished in an age of great scientific advances, but also of intense intellectual debate and challenge. His main challenge was to unify the laws that governed the heavens and the earth, showing that the universe obeyed a set of coherent principles. In his magnum opus, Principia Mathematica, published in 1687, Newton presented his three laws of motion, which explained how objects move and how they interact with each other, from a simple ball to the planets. But his greatest achievement was the formulation of the law of universal gravitation, which showed that the same force that makes an apple fall to the ground is the same force that keeps the moon in orbit around the Earth and the planets around the sun. This law revolutionized astronomy and physics, providing a mathematical framework for understanding the structure and functioning of the universe. Newton also made important discoveries in optics, demonstrating through experiments with prisms that white light is composed of all the colors of the spectrum, and is not a pure, indivisible entity as previously believed. In addition, he developed infinitesimal calculus, an essential mathematical tool for physics and engineering, which made it possible to analyze motion and change with unprecedented precision. His work was not without controversy, especially with Leibniz, who also developed calculus independently, leading to a long dispute over the priority of the discovery. However, the impact of Newton's discoveries was so profound and transformative that it changed the course of science forever. His laws and theories became the foundation of classical physics, and his legacy continues to be a source of inspiration and a basis for scientific and technological development around the world. Isaac Newton's legacy is immense and his influence endures to this day. His laws of motion and the law of universal gravitation are pillars of physics and engineering, essential to understanding the universe. His work laid the foundations for space exploration, allowing the trajectories of rockets and satellites to be calculated. His development of infinitesimal calculus is key in numerous scientific and technological disciplines. But beyond his technical achievements, Newton left us a valuable method of research, rigorous observation, controlled experimentation, and the formulation of mathematical laws. His ability to connect seemingly disparate phenomena and find universal laws teaches us the importance of curiosity, perseverance, and the search for truth through reason. Newton proved that the universe is not an incomprehensible mystery, but can be understood by the human intellect. His work continues to inspire scientists, engineers, and explorers to search for answers to the great questions of the cosmos, from the nature of matter and energy to the origin and fate of the universe. His legacy is a reminder that the pursuit of knowledge is a never-ending journey, and that the human mind has the power to transform our understanding of the world, driving progress in all areas of knowledge. Newton's influence extends far beyond science, permeating our culture and our way of seeing the world, and he remains a symbol of the human capacity for genius and discovery.